Good evening, Ireland. This is JWST+2. The James Webb Space Telescope has been in operation for over 2 years now. And I'm going to say a little bit about the telescope, but mainly about what it's been doing for the last year or so. So just a little bit of a recap. The James Webb Space Telescope, hereafter just the Webb, or perhaps JWST, was launched on Christmas Day 2021. Because it was a Christmas Day launch, that's why I put a little bit of holly and ivy in the corners of this particular slideshow. You can see in the pictures here, it's a rather large telescope. It had to be folded up and then placed on the top of a rocket and sent out into space. And it's not orbiting the Earth like the Hubble Space Telescope. It's sitting out here at a parking place, colloquially known as L2, or Lagrange point 2. It's about 1 million miles away from the Earth. So the daylight side of the Earth here, facing the sun, that's where noon would be. And the side of the Earth facing away from the sun is midnight. And the L2 point is floating above midnight, about 1 million miles away. So you could say that the James Webb Space Telescope is floating 1 million miles above midnight. I'm not going to be talking about the orbital mechanics of how they decided that was a good place to put it, but it's an infrared telescope. They want to get away from heat sources, they want to get away from the moon and the Earth and shield from the sun, and they decided that was the best place for it. Now, what's it going to be doing? Amongst other things, it's going to be looking back in time. Because it's going to be looking at very distant galaxies amongst other objects, and because the speed of light is finite, it takes a finite length of time for light to travel from one point to another, the more distant the object you're looking at, the further back in time you're looking. So the universe was created in the Big Bang about 14 billion years ago. So here's the Big Bang at 0, and then 2, 4, 6, 8, 10, 12, 14 billion years later, that's us here now. These numbers across the top, these red numbers, indicate how much the light has been stretched the further back in time we look. Again, I'm not going to go into the details, but the universe is expanding, and that means the further back in time we look, the more the light has been stretched. And these numbers in red indicate how much the light has been stretched. So why is the James Webb looking back in time? What we want to do is to be able to see the earliest stars. When were the first stars or the first galaxies made? And we think that was a long time ago. We have to go all the way back to that first 1 billion years, that period here indicated between the blue lines. We think the first stars and the first galaxies were made all the way back then. If we blow that up so we can see it a little more clearly, instead of indicating in billions of years, now let's indicate in hundreds of millions of years. So we think the first stars and the first galaxies were born sometime in this period, a few 100 million years after the Big Bang, but we don't know exactly when. The Hubble Space Telescope has been looking back as far as it can and has reached about that point there, about 500 million years after the creation of the universe. The James Webb Space Telescope is working in the infrared, and that makes it easier to see a little further back in time. And it's hoped that the James Webb Space Telescope, once it's been in operation for a few years, will be able to push that back even earlier and perhaps see back to 100 or 200 million years after the creation of the universe. And maybe at that point we will find the very first stars and galaxies. So that's one of the purposes of the James Webb Space Telescope. A lot of scientific results, images and spectra were released a few months after it was launched on Christmas Day 2021. By the middle of 2022, it was starting to produce images. I'm not going to be talking about those first images. I'm trying to give an update of what it's been doing in the last year or so. Now, if we look at spring of last year, spring of 2023, this image was released. It's a very massive star. All of the stars show up with this characteristic 6-pointed star. This is nothing to do with the star itself. The 6 spikes coming out of every star are just a result of the way the telescope works. So this very massive star we think is coming to the end of its life. This star is called Wolf-Rayet 124, a rather odd sounding name. It's a very massive star which for thousands of years has been losing a lot of its outer atmosphere, and that's produced this pink nebula that we can see in the background, this thing that looks a little bit like a flower or the petals of a flower. So we think this star is rather unstable because it's very massive and because it's coming towards the end of its life. It's starting to lose its outer atmosphere and produce this background nebula. And we think perhaps this star is going to go supernova, explode and seed all of the surrounding interstellar medium with the contents of this star. Once it explodes, the entire star will effectively be destroyed. So it's not quite there yet, but stars like this are being watched because we think they will be going supernova before too long. James Webb is also looking at some much closer objects. For instance, here we have a ringed planet. No, not Saturn. This particular ringed planet is Uranus. This has been visited by spacecraft like Voyager, for instance, many decades ago, but James Webb is able to look at the outer planets, Jupiter, Saturn, Uranus, Neptune, and it sees an awful lot of structure. Spacecraft can get much closer, but spacecraft might only be flying past the planet for a few hours, whereas James Webb in principle can go back and look at these planets essentially any time it wants to, and it can see changes on the planet. In this case, for instance, there seems to be a very bright spot on the left-hand part of the planet as we're looking at it. It looks like there's a storm system developing on Uranus when this particular picture was taken and released in the spring of last year. In addition to planets within our solar system, it's also possible for James Webb to look into the rather dusty environments in planet formation around other stars. This is the second reason that James Webb was placed into space, not only to look back in time at very distant galaxies, but to also look at very dusty environments such as the dust and gas that's forming stars and the dust and gas that's forming planets. Here a star seems to be forming planets. The star itself has been blocked out by this black circle at the centre because the star is so bright. And by blocking out the starlight, it's then possible to see this fainter, dusty region, which we think is a planetary system in the process of formation. Just like our solar system appears to have a band, an asteroid belt of small rocky debris, as well as a Kuiper belt, some icy debris a little further out, it looks like this particular planetary system also has something that might be akin to an asteroid belt and perhaps a little further out a Kuiper belt. That doesn't mean that all solar systems will develop this way, but it's interesting to look at other solar systems around other stars to get an idea of whether our solar system is typical or whether all solar systems are very different. And looking at other solar systems gives us an idea of how our solar system formed. Again, going back and looking further afield, this was in the summer of last year. This image was released. It was Astronomy Picture of the Day. That's what it means down at the bottom there, APOD. It was Astronomy Picture of the Day in June 2023. And this is a mosaic of a very large star cluster called Pandora's cluster. And this image was released as an indication of just how much detail the Webb can see. There's lots of foreground galaxies that look quite white and fuzzy, and there's lots of background galaxies that tend to be a little smaller and a little bit redder. There aren't that many stars in this particular image. Anything that's got 6 spikes in it is probably a star. So there's a very pronounced star there. There's another one over in the top left, another one in the top. But virtually every other dot that you can see in this sort of image is a galaxy. And therefore there aren't simply hundreds or thousands, there are probably tens of thousands of galaxies in a mosaic image like this. And therefore there's a huge amount of data that the scientists can use to try and understand galaxies, galaxy formation, and generally the structure of the universe. If we come again a little bit closer to home, again now looking inside our own galaxy, James Webb is tasked with looking to see if we can see how stars themselves form. In this particular case, this is a rather dusty environment, and so the star itself hasn't been deliberately blocked out, but there's so much dust in this central region that the star that's being born here, right in the center of this image, can't be seen because not even the James Webb can see into this very dusty environment. But we know a star is being born in this region because we can see these huge jets coming out in the top right and the bottom left. As the cloud of gas collapses and forms a star, somehow these jets are formed, which is spitting out a huge amount of material into the interstellar medium, into the space between stars. And as these jets leave the stars, they produce shock waves as the jets travel through space. Space isn't truly empty, it's just a rather rarefied gas, very few molecules floating around, but those jets will still produce shock waves. And by analysing what these jets are doing, in particular, scientists have been looking at the structure of these jets, and they appear to be twisted or braided. And they think that this is a sign that what's going on right at the center of this system is that a double star is being born, and those stars are circulating around each other, producing these twisted jets. So perhaps what we're witnessing in an image like this is the birth of a double star, the birth of a binary star. As well as the birth of stars, James Webb is also looking at stars that have died. This is the Crab Nebula, a so-called supernova remnant. After this star went supernova, which happened about 1,000 or so years ago, this is what's left. Most of the material that used to be inside the star has now been ejected and thrown out into the space between stars, producing this rather spectacular nebula. As well as looking at the detail and trying to figure out what elements are present and how did this supernova actually occur, it's interesting to note that this object has been seen previously by the Hubble Space Telescope. Some 20 years earlier, Hubble produced an image of this supernova remnant, and there it is. If I swap backwards and forwards between the James Webb image and the Hubble image, perhaps you can see there's a slight difference in the size of the image. If you concentrate on one particular feature, for instance, if I go backwards and forwards, perhaps you notice that the nebula is a few % bigger in the James Webb image because it was taken 20 years after the Hubble image. And this supernova went off 1,000 years ago, so in 20 years it's grown just a little bit bigger. It's a few % bigger because 20 years is a few % of the 1,000 years that this nebula has been growing since the star went supernova. Now, when a star dies, when a very massive star dies, it might produce at its very core a very dense neutron star or even a black hole. And black holes are very interesting for lots of different reasons, not least because we think there are really large, so-called supermassive black holes at the centers of lots of galaxies, perhaps even every galaxy, our own included. So this is the Pandora cluster again, but this time the scientists are homing in on one of the galaxies shown in the middle of this particular square here. And no, it's not this white object that we can see that the cursor is now pointing at. It's this tiny little object in the center of the circle. That one is interesting because a different telescope, the Chandra telescope, has indicated that that particular object is emitting lots of X-rays. And that's a characteristic sign that this is probably a very energetic source, probably a supermassive black hole. And this particular combination of observations, Chandra saying that this object is emitting lots of X-rays, so is a black hole, and James Webb indicating that there's a galaxy there, we can hardly see it, it's quite faint, but James Webb is able to take the spectrum of this galaxy, and the spectrum allows us to measure the change in the wavelengths of light. Remember, light gets stretched because of an expanding universe, and by measuring how much that light is stretched, that tells us how far away the galaxy is. And so this combination of the James Webb with other telescopes has allowed us to determine that this is the most distant black hole ever observed. It is some 500, it was imaged some 500 million years after the Big Bang. In other words, we're looking back in time more than 13 billion years. Remember, the universe is 13.8, nearly 14 billion years old, and we're looking back here to only a few 100 million years after the Big Bang. And James Webb, in concert with Chandra, has been able to show that really big black holes existed even that early in the universe. And this is rather important for our understanding of how the universe began and how the universe ended up looking the way it does. Black holes seem to form very early on, much earlier than we had previously assumed. Many people thought it would take billions of years for stars to collapse into black holes and form these really big black holes at the centers of galaxies. And yet it looks like perhaps, no, that's not the case. They must form very quickly because this is a very early example of a supermassive black hole. Now, I said that the James Webb Space Telescope has been producing science for 2 years, but remember it was launched Christmas Day 2021. So you could argue that James Webb is actually 2.5 years old. So let's bring this talk bang up to date by having a look at the very latest results from the James Webb only a few months ago. So in June 2024, it released this rather beautiful image of a lot of stars being born from a nebula, a cloud of gas that is collapsing and forming not one, but a whole host of stars. Our sun is on its own. It's a solitary star, but we think that most stars are born in clusters by the 100 or by the 1,000 or by the tens of thousands. And our sun was probably born that way and has drifted away from its siblings, its brothers and sisters, and is now on its own. But here we have a relatively close star system in which the James Webb is able to see a lot of detail in the individual stars that are being born out of this large cloud of gas. And one of the reasons this is important is by looking at these individual stars and all of the gas, some of which is collapsing in and some of which is produced by the jets coming out of these stars being born. That's telling us something about the way the stars are being born and the way they're forming and the way they are spinning. It has been thought in the past that if a huge cloud of gas collapses and forms thousands of stars, perhaps all of those stars would end up spinning in the same direction, but we weren't sure. Now the James Webb has been able to analyze images like this and has been able to show that yes, indeed, stars end up spinning in the same direction when they're born from the same cloud of gas. Again, going more remotely, but still in June 2024, the James Webb has done a lot of surveys, including this so-called deep survey, meaning a long exposure, going a long way into distance and hence a long way into the past. One of the things it's been able to do is identify lots of galaxies indicated by these blue circles, lots of galaxies that contain stars that have gone supernova. You can't see any detail in the tiny dots within these circles, but by careful analysis, it's been determined that all of the objects inside these blue circles are supernova. And it's important that James Webb looks at objects like this, not because we are necessarily interested in stars that are dying, but because supernova are very important pieces of information about the distance of galaxies. If all of these supernovae are the same brightness, then a supernova that looks faint must be in a more distant galaxy than a supernova that looks quite bright. So it's really important to know whether or not it is indeed the case that all of these supernovae are the same brightness, because if they're not, that means we can't use them as an indicator of how distant a particular galaxy is. And that's what we've been doing for many years. We've been assuming that supernovae are a good guide to the distance to a galaxy. So it's important that James Webb actually tries to establish whether or not supernovae are a good guide to distance. Because if we've got that wrong, we've got the size of the universe wrong, and we need to rethink some of our models that explain how the universe came to be and how the universe has been expanding. Again, in June 2024, just basically a few weeks ago, this was Astronomy Picture of the Day in late June 2024. Here again, we're looking at a large field of galaxies, but there's one galaxy in particular in that tiny box. If we blow it up, it doesn't look very spectacular at all. The galaxy, the rather reddish looking galaxy indicated by the arrow. But by analysing the light from this galaxy, we realize that the light from this galaxy has been stretched more than any other galaxy that we've seen. In other words, this has been stretched more, so it must be a more distant galaxy. So it's relatively bright, but it is very, very remote. It's the oldest and hence most distant galaxy that has been observed to date. If we go back to our timeline, remember we think stars and galaxies were born in the first few 100 million years after the Big Bang. And this number in red indicates how much the light has been stretched by. And this last observation takes us back all the way to a stretch of 14. In other words, this particular galaxy, we're seeing it as it was only 300 million years after the Big Bang. As time goes by, as James Webb makes more and more observations, we'll be pushing this further and further and further. So we know that stars and galaxies existed at this point because we've seen them in the last image I showed you. The question is, if we try and go back further in time to 250 or 200 million years, will we continue to see early stars and galaxies, or at some point will we simply not see any more, indicating that stars and galaxies didn't exist until that particular point in time? It may take months, it may take years for James Webb to make more observations to push this to earlier and earlier times. But every image that it takes gives us a little more understanding about how the universe came to be and how the universe ends up looking the way it does. Let me finish with a couple of images. This was the second anniversary image. In other words, 2 years of scientific output from the summer of 2022. This was the summer of 2024, and to celebrate the second anniversary, they published this image of two galaxies interacting with each other. A big spiral galaxy on the right, which is very distorted by the gravitational pull of this bluish galaxy on the left. And this pairing has come to be called the penguin and the egg. Some people think this object on the right looks more like a hummingbird than it does a penguin, but let's not argue about that. It's very interesting to note there's an awful lot of physics going on. There's a lot of science to be teased out of an image like this, because when we look at the interaction, the gravitational pull of these two galaxies, we learn a lot about galaxy evolution, why galaxies are the way they are. We also realize that when one galaxy pulls on another, it can actually start a whole load of new star formation. So some of these bright patches here, that's the original galaxy at the top. The eye is the center of the original galaxy, and a huge amount has been pulled off and new stars are being formed in this region because of the gravitational interactions with the neighboring galaxy. So whenever galaxies get close to each other, it's not the end of a line if galaxies collide with each other. On the contrary, it's new birth. New stars are being born whenever galaxies collide with each other. And to bring it bang up to date, the most recent image I could find was one that was released on Monday. So this was the 26th of August 2024. An image again of the very deep part of the universe, a set of galaxies. Some of those are relatively close, these large white looking galaxies where we can see some structure, some spiral structure. These must be relatively close if we can see that level of detail. And the tiny dots, especially the tiny orangey and red dots, are more distant galaxies. Again, we've got possibly half a dozen stars in this particular image with the spikes there. Virtually every other dot you can see in the image is a galaxy. And the James Webb Space Telescope is taking lots of images like this of galaxies near, galaxies far, looking at the amount that the light has been stretched for these distant galaxies to give us a distance indicator and to give us some indication of how galaxies have evolved. What we're trying to do is establish, have we got our ideas about the universe correct? We think it was born, the universe was born 13.8 billion years ago, and ever since it's been expanding and the galaxies have been getting further apart. By taking images like this and doing a lot of analysis of the structure of the galaxies, the distribution of the galaxies, even the colour of the galaxies, hopefully that will reinforce our understanding of how the universe came to be and how the universe is the way it is. So that was a whistle-stop tour, including some of the latest images from the James Webb taken in the last few weeks, last few months, last year or so. Thank you all for listening.